In this increasingly digital world, the way we store and manage our data has a significant impact on its security, availability, and accessibility. Hey everyone, welcome to Money and Tea with Dave and Josh. Today we'll be discussing the importance of decentralized storage and what it means from different perspectives. Centralized storage, as the name suggests, involves storing data in a central location, typically within a single data center controlled by a central authority. While this approach has been widely used in the past, it has some vulnerabilities. For example, centralized storage often lacks sufficient data privacy measures, exposing data to the risk of unauthorized access and data breaches. Imagine a large corporation storing customers' data on a centralized server. If a breach occurs, all customers' data could be compromised, leading to severe consequences for both the customer and the company. So now that we know what centralized web is, let us find out why is decentralized and distributed file storage critical for a better web. The team behind IPFS and Falcon explains how advances in distributed data storage and strong alignment of market incentives are combining to create a much more secure and efficient web. In the span of less than 3 decades, the web has become one of the greatest achievements in human history, responsible for never-before-seen gains in science, technology, and commerce. This amazing growth has been driven in largely by technologies abstracting away much of the underlying complexity of the internet. One of the biggest of this abstraction has been centralized cloud storage, where data is stored in large centralized silos owned and run largely by for-profit corporations. This architecture makes the web brittle, undermines privacy, allows the price of storage to remain artificially high, and creates bottleneck that prevents innovative new users of data. The web need not be structured this way. Imagine new technologies are allowing us to improve the web's underlying protocols by addressing contents by what it is, rather than addressing it by where it is. This makes the web a much safer and robust place, where we're far less reliant on any one particular entity to give us the data we request. Now, instead of relying on expensive businesses to store and transmit humans' trove of knowledge, we can distribute data across a vast network of peers who are paid to store each other's network. Decentralized storage makes the web robust and resilient. Today's information on the internet is addressed by location. A particular piece of content has a URL, a universal resource locator, that involves the IP address of a web server that hosts the content at a specific location. For example, to go to a URL like facebook.com mypicture.jpg, we resolve the domain name Facebook into an IP address, example 31.13.3.70.36, and look up the picture there. The URL is saying go to this address and request the content and the path. Okay, the URL always point to that location. If the same picture was hosted on another site or even your own computer, you would still have to connect the IP address and download the content. It's useful to think about this in everyday human context. Imagine that we could only reference books by the physical location of a copy, not by the title, or author, or ISBN, only the location of the physical object. So if someone told you to read a book, they'll say something like, hey, you should read this great book. It's at the New York Public Library, Section 9, Bookcase 3, top shelf, first from the left. And now you have to check that and get a one physical copy. Until you do, you don't know what book it actually is. You only have the location. This is obviously terribly inefficient. It's also a precarious situation. What if someone moved the book? What if the library is closed that day or totally shut down? Or what if you get there, you get the bookcase shelf, top shelf, first from the left, and you realize this whole time you had another copy of that same book in your backpack? This isn't just a theoretical concern. A recent Harvard-led study found that 49% of all hyperlinks cited in US Supreme Court opinions are no longer working. The opinions point to locations that held the correct content at the same time in the past, but the content is no longer available at that location. This is brittle, inefficient, and unnecessary. This is madness. Okay, let's see. Instead, consider a different way. Consider addressing information by what it is, not where it is. To do this, we need to use a different kind of web link. Instead of using links that points to locations, we need links that uniquely describe the content itself, like a fingerprint. This content address approach separates what from where, so data can flow through the network, so it can be stored and served from anywhere by anyone. To create this content address link, we use the content cryptographic hash as the unique identifier or fingerprint. IPFS, the Interplanetary File System, is a protocol that lets us use these content address links to exchange data in IPFS. The hash fingerprint of a file or piece of data is its address. We use these fingerprints to identify the content instead of using the physical location of the server. This way, when you're trying to load a file, you retrieve it from any place you can. If the file is already on your own computer, you can retrieve it from there. If your direct neighbors in the network have the file, you could retrieve it from them. You might get it from the original server, from others in the network, or whoever. So IPFS handles this all for you using efficient routing algorithm to search the network, and it can be tuned for privacy. Only request data from peers you trust. This is similar to what other peer-to-peer systems do, but greatly amplified. You can use it to exchange any kind of file or data with any numbers of peers, and it's built directly into the web. IPFS decentralized the web by addressing information based on what it is and not where it is. This decentralized pattern lets web applications work in local networks disconnected from the original source. Whether it's a chat room in an office that lost its uplink, a scientific paper hosted in variety of libraries, Wikipedia in a remote village with poor connectivity, or a family chat messenger during a crisis. It strengthens our digital information, making the data resilient to failures in the underlying internet, securing it cryptographically, and giving it permanence through time. You or the people whom you shared your data with can save copies of data and count on the same links for years. IPFS allows file storage on the web to be decentralized, but a second question remains: how can we create an open, competitive market for providing that storage? Cloud storage and the dangers of centralization. Okay, since its inception, cloud data storage has evolved to be functional, but leaves too many economic and security concerns unaddressed. In order to understand why cloud storage is currently expensive and precarious, it's useful to examine its evolution over time. The earliest website and online services run their own web servers, computer and hard drives dedicated to serving content to their users. Before an online business could sign up for their first customer or sell their first product, they have to completely invest formidable sums of money and time in setting up server infrastructures. Even if the product or service was completely unrelated to computing and data storage, virtually everyone was forced to invest and run their own hardware just to have a web presence. That was expensive, wasteful, and time-consuming. In 2006, Amazon.com addressed this wasteful overhead and boldly launched Amazon Web Service. AWS removed the need for developers to create and manage their own server infrastructure by renting out Amazon's own server and storage space to others. Now, for a modest fee, a company could easily store and serve their files from Amazon, negating the need for that company to buy their own hardware. AWS became a quick hit, and several other large technology firms followed suit in creating their own cloud-based storage solution. Cloud storage allowed new online businesses to spring up overnight and grow to match its users' demand quickly. Instead of ordering new hard drives and installing them in their own small data centers, cloud computing allowed businesses to scale up at a moment's notice with a few keyboard strokes. In just a few years, cloud computing becomes so useful and popular that majority of all data becomes stored in just one of these few cloud data providers. This infrastructure is still largely invisible to the end user. Even though most websites today are hosted by these third-party providers, for example, do you know that Netflix, the popular movie streaming app, actually use AWS for much of their hosting needs? Even though Amazon has its own rival movie streaming service, Amazon Prime, they're also happy to sell hosting space to a competitor. Even more frustrating, there exists a significant amount of latent storage throughout the world that sits unused. This storage is owned by all kinds of entities, large corporations down to small family businesses, individuals with huge hard drive racks in their basement to small drives in everyone's laptop. However, due to the aforementioned barriers to entry, it will be difficult for any one particular company or individual to monetize their extra space and start a cloud data service. A much more efficient market would decouple raw hard drive space, example the storage, from all the services and support on top. The customer service, user interface, payments, and price negotiations. This will allow for a diverse and dynamic market of hard drive providers to focus on owning the hardware and compete in the proper market for storage itself, which would greatly reduce the price of cloud storage and allow vast monetization of existing capacity. It would make cloud storage more like commodity or utility that you buy as you need at a going market rate, and less like a service relationship fraught with contracting, negotiation, transaction, and lock-in costs. But the question remains, how can we build a true decentralized storage ecosystem? Content addressing is solved by IPFS, but how can we encourage people all over the world to become the backbone of storage itself? And the answer is Filecoin. Filecoin, paying the network to store your data. While IPFS lets us exchange data directly with our peers instead of relying on centralized hosts, Filecoin take it a step further by giving us a way to pay each other for storing data. Filecoin is a decentralized file storage network and protocol token. Think of it like an Airbnb data storage. On its supply side, the mining side of the token, individuals and organizations with unused storage space can add their space to Filecoin network and receive client orders. On the demand side, clients, individuals, and organizations hire the Filecoin network to store their data, which get routed to many different miners worldwide. Protecting privacy and decency on the decentralized web. Storing private data on a network powered by IPFS and Filecoin means that part of the data may be distributed across many computers operated by complete strangers. Remarkably, however, this can be better for privacy than existing cloud systems. Today, a large variety of cloud storage providers, big and small, store their users' data entirely in the clear unencrypted. Even some who have added encryption at rest have done so by controlling their users' encryption keys instead of creating truly oblivious or zero-knowledge systems. This is a dangerous arrangement because it means that customer data can be stolen and leaked or sold by hackers and other attackers. Users should encrypt their data end-to-end before giving it to these cloud storage providers, whether centralized or not. Distributing user data to large arrays of storage computers who are not owned by one company or service can increase the exposure of the data. However, if valuable data is stored end-to-end encrypted, the attackers with access to the encrypted text cannot learn what is inside them. This is true whether the storage network is a big cloud provider or an incentive market like Filecoin. This is a different security model, where we are forced to always encrypt everything with only users' access to the key, and where the failures of a single cloud provider cannot harm the resilience of the data. Let's see. Market protocols harnessing networks and incentive to create better industries. At Protocol Labs, we believe that market protocols, decentralized networks that are powered by protocols token are the next wave of internet innovation. We believe these technologies have the potential to reshape how we organize commerce and transact value worldwide. This is partially because market protocols present a completely new dynamics between incentives, participants, and a network ability to create value. In the current model of internet innovation, when companies create a network economy, they capture the majority of the network's value. Through millions of people participate in creating value on the network, these participants are likely not earning a stake in the network itself. The majority of the long-term value is awarded to a small number of wealthy investors and early stakeholders. By contrast, market protocols are fueled by protocol tokens, which are a percentage of the network's overall value. The compensation for participating in a market protocol is a stake in the network, which grows and shrinks with the value of that network. For instance, Airbnb and Uber are companies that have built network economies. They compensate service providers with service fees, not a share of the overall wealth created by their networks. This ensures that a small number of shareholders are greatly rewarded, while the people who help the network create values may not share fairly in the upside. Networks like Filecoin embodies an alternative where participants who create the network's value are compensated with a stake in the network. Miners who store and distribute data on the Filecoin network earn the Filecoin protocol tokens, which they can choose to hold or liquidate into cash. Since Filecoin protocol tokens are designed to track the amount of value created by the network storage network, growth in the Filecoin economy will translate to growth in the value of the token. Miners and users who choose to hold the token will share in that upside, earning fair rewards for the creation of value. The more tokens an individual participant earns and holds, the more incentive they have to support the network and ensure its success. This incentive alignment and feedback loop causes an extremely strong network of collaborating participants who will all greatly benefit from the success of the network. Market protocols are still in their early stages and development, and their promise is great. We're excited to be on the forefront of these technological advancements and that are making the internet and its web of data more secure, robust, and fast. Just as the web has created massive connectivity and unlocked human potential, we think the next wave of market protocols will do the same for the future. Okay, now that we know what decentralized storage network brings for us, let us view this from a few different perspectives. From the user's perspective, imagine you're an individual who heavily relies on cloud storage services to store your personal files and documents. With centralized storage, you might have concerns about the security and privacy of your data. However, by adopting decentralized and distributed file storage, you can have peace of mind knowing that your files are encrypted, distributed across multiple nodes, and under your control. This empowers you to safeguard your data and protect your privacy. From the developer perspective, as a web developer, you understand the importance of data availability and performance for delivering a seamless user experience. With centralized storage, you may face limitations in terms of scalability and data redundancy. However, by integrating decentralized and distributed file storage into your applications, you can leverage the collective storage resource of a network. This enables a faster content delivery, improved fault tolerance, and reduced dependence on a single server, leading to better user experience and higher customer satisfaction. From the business perspective, consider a small business that relies on a centralized storage infrastructure for its critical data. Unfortunately, a server failure occurs, resulting in data loss and significant downtime. This can have severe consequences, including financial loss and damage to the business reputation. By adopting decentralized and distributed file storage, the business can mitigate such risks. Distributed data across multiple nodes ensures high availability, minimizing the impact of the server failures and enhancing business continuity. Okay, from the perspective of a content creator, as a content creator, you produce and distribute digital content such as videos, music, or artwork. With centralized platform, you might face challenges in terms of content censorship, limited monetization options, and lack of controls over your own creations. By leveraging decentralized and distributed file storage solutions, you can store your content in a censorship-resistant manner. Moreover, utilizing blockchain-based systems, you can directly monetize your content, engage with your audience, and retain ownership and control over your creative work. And from the data preservation perspective, imagine you work in a cultural heritage organization, tasked with preserving and archiving valuable historical documents and artifacts. Centralized storage systems may not provide sufficient guarantees for long-term data preservation. However, by adopting decentralized and distributed file storage, you can ensure the integrity and accessibility of these valuable assets. The distributed nature of the storage network enhances data redundancy and reduce the risk of data loss, ensuring that future generations can access and learn from these historical resources. By embracing these technologies, users, developers, businesses, content creators, and organizations can address concerns related to security, privacy, scalability, availability, content censorship, and data preservation. Ultimately, decentralized and distributed file storage lays the foundation for a better web, empowering individuals and enabling a more resilient and inclusive digital ecosystem. So that's all on why this decentralized and distributed storage network is critical for the web. And remember to press the like and subscribe button if you like our content.